Hi, this is Mrs. Often, and we're here today to talk about solving trig equations. Just a few reminders of things that will be helpful to you in solving trig equations, especially those involving the right triangle. Here's a triangle. It's obviously a right triangle because it has a hypotenuse here across from the right angle. My angle theta is labeled, the adjacent side and the opposite side. The sine of theta is defined in the right triangle as being the ratio of the opposite side to the hypotenuse. The cosine of theta is the ratio of the adjacent side to the hypotenuse, and the tangent of theta is the ratio of the opposite side to the adjacent side. First way that I might want to solve a right triangle is trying to find a missing side length. So in my right triangle, I have 3-meter side, 23 degrees, and I'm looking for the length of the hypotenuse. So the sides that have labels on them, or that I'm trying to find measures for, are the side opposite the angle and the hypotenuse. So looking back, I could say, all right, that's a sine ratio, opposite over hypotenuse. So I'm just going to write down sine theta equals opposite over hypotenuse. And I'll fill in everything I know. I know that the opposite side is 3. I don't know the hypotenuse. And I know that theta is 23 degrees. In order to get this h out of the denominator, I'll multiply both sides by h. So this gives me that h times the sine of 23 is equal to 3. If I divide both sides by the sine of 23, then I can isolate h. And I've got my calculator with me because I don't know the sine of 23 degrees right off the top of my head, but I'm just going to calculate 3 divided by sine of 23, and I get this value for the hypotenuse, 7.7 meters. Looking at my picture, 7.7, that looks pretty reasonable. I'd say that looks good. Okay, I know that 3 meters is the shortest side. It's across from the shortest angle or the smallest angle. 7.7 had better be pretty big. And the function that I used to solve that was sine of theta. Okay. We also could solve for an angle in a right triangle. So once again, I look at my picture here. I have my angle theta. I don't know its measure, but I do have the adjacent side, 70 meters, labeled. I have my opposite side, 100 meters, labeled. And so adjacent divided by opposite is defined of the tangent ratio. So tangent of theta is equal to adjacent over opposite. And so if I fill in everything that I know, I have adjacent, and I just wrote that wrong. That's the cotangent ratio, so ignore that. Tangent is opposite over adjacent. We'll just fix that right now before getting ourselves into any further trouble. So 100 over 70. I'm sure at least some of you at home were going, oh my gosh, how could she have made such a mistake? But I do at least know that this is not a value I recognize from the unit circle. So I'm going to use my calculator again and use the inverse tangent function. Remember that the inverse tangent function tells me what angle has a tangent equal to 100 over 70. So calculating that right now, I get that theta is equal to approximately 55 degrees. And again, looking at my picture, This side is definitely larger than 70. I do expect it to be across from a larger angle. So my answer seems reasonable. Okay, so that is solving a right triangle. Now we also may be asked to solve functions that are on the unit circle. So I just wanted to put this up as a reminder of function values in various quadrants. In the first quadrant, all the functions are positive. Sine of theta greater than 0, cosine greater than 0, tangent of theta all greater than 0. In the second quadrant, only the sine function is positive, but cosine and tangent are both negative. In quadrant 3, sine and cosine are both negative, and since together they involve opposite and adjacent, then the tangent ends up being positive. So tangent is positive in quadrant 3. And finally, in quadrant 4, we have sine is negative, cosine is positive, and tangent is also negative. So we have a mnemonic for this. All students take calculus. And this is just a little mnemonic device that helps you remember which functions are positive in which quadrant. So we'll use this as we solve problems in all 4 quadrants. Okay, our questions will usually say something like solve in the interval 0 to 2 pi. Our goal will be isolate the trig function, use the inverse function, then use all students take calculus and theta prime, the reference angle, to determine our answers. I'll start by isolating the trigonometric function. I'm going to subtract 1 on both sides. I have 2 sine x equals -1. That tells me that sine of x is equal to -1/2. Okay. Now, I know that since the sign has to be negative, I'm either in quadrant 3 or in quadrant 4. If I take the inverse function, inverse sine of just +1/2, that's going to give me my reference angle, theta prime. So my theta prime value is going to be 30 degrees, or pi over 6. So I'll draw my reference angle here in quadrant 3 and here in quadrant 4. The quadrant 3 angle that has a 30-degree reference angle is 210 degrees. The quadrant 4 angle that has a 30-degree reference angle is 330 degrees. So this has 2 different answers depending upon what quadrant you need to be in. If it gives you this 0 to 2 pi interval, you should be reporting both answers. However, in a word problem, you probably want to report what makes the most sense for the situation you've been given. Let's look at one more example of this involving tangent. Now, we'll be working a lot with the tangent this year as we study vectors. I have the same setup pretty much as my previous problem. So I'm again going to begin by isolating the trigonometric function. I'll add 1 to both sides. And so I have 5 tan theta equals 5. And tangent of theta equals 1. Now, tangent is positive in quadrant 1 and quadrant 3. So I'll go ahead and find the inverse tangent of 1 to get my reference angle, theta prime. And I find that theta prime equals 45. So my angle in quadrant 1 is still 45. In quadrant 3, I draw that reference angle of 45 degrees. And I get my answer by adding 180 degrees, of course, to get my second value, 225 degrees. So that's your basic procedure for solving trigonometric equations either with the right triangle or in all four quadrants.